Hey guys, today we're gonna walk you through the bank loan dataset. So the dataset is about the approval of bank loan and assume that we are the bank managers. And here we go. First of all, we import some libraries, of course, and we import the dataset. And we select the numerical features and categorical features from them. And uh, and we draw some charts to identify the outliers, and we can see there's some outliers in the data set. We also draw a correlation matrix to visualize the correlation between each variables. And next we go to feature engineering, and this is the step we want to do to improve the performance of our model. And of course, we first map the categorical variable previous low and default zone file is a yes or no. So we map it into one zero so that the model can interpret it. And also we've been in the ages. We divide them into several groups which are young, middle age, adult, and senior. And we also want to transfer the age group into dummy variables so that the model can interpret it. And of course, we don't think there's any difference between young and mid-age. There's no sequential order within them, so that's why we want to convert it into dummy variables. And then we add some uh, default variables to the dataset, and this is same as the sample text notebook. And we would think that the debt to income ratio is an important factor, as well as the income per year experience and the loan interest burden, and income to loan ratio, the credit history to age ratio, the ex, ex, employed experience to age ratio. And we think that they are important factors to predict the loan status. And also we assume that there's a sequential order within the education level. For example, if I am a bank manager, I would say that there's higher possibility for a doctorate for a person with doctorate degree to pay back his loan compared to a person with only a high school degree. And so that we think there's a sequential order within them. That's why we encode it into label encoder. And this is the code we want to we place them from high school to doctorate degree from 0 to 4. And we also think that the lower intent is an important factor. And also there's a sequential order within it because we think that uh, the people who want to adapt to consolidate their loans, it's a ideal customer for us. And also people who want to uh like borrow money from the banks so that they can do some venture uh investments. We don't think they're good customers. So that's why we are encoding from 0 to 5. And of course, the ownership of the houses. Like, for example, if I have a house, I have a possibility to pay back my debt. So that's why we think it has the highest ranking among all ownership status. And that's the encoding step. And there's also a step we want to do to improve the accuracy, improve the performance of the dataset, of the models. And we don't think gender is an important factor in the model, so that's why we drop it. And also we scale the numerical features and scaling between -1 and 1 so that they are centered to 0 and more distributed. And as we can see, there are some imbalance in the low-end status. Like there are a lot more zeros than ones, so that's why we want to oversample the ones in the data set so that they can have a balanced distribution. As we can see, we use the Edison um, oversample strategy to oversample it, and they're equally distributed. Uh, and here comes our model. And we first use random forest 2 as a baseline model, and we submitted the result to the Kaggle. It is not a good predictor, so that's why we use other models other than the Baggy models. And we tried the light GBM. We tried XGBoost. We also tried some algorithms like gradient boost, data boost, cat boost, and among all, the light GBM is the best model, and that's why we use it. And we fine tuning some hyperparameters of the classifier. For example, the estimator numbers, the max depths of the trees, and the number of leaves, etc., etc. And we also draw a learning curve of the model. We can see as the training set size goes bigger, the close the cross validation score and training score gets closer, and the confusion matrix is also like this one. We can see there are a lot of true positive and true negative outcomes, and this is what we want to see. And finally, if we have more time on resources, what will we do to further improve our classifier? Well, I would try the neural network because it's a complex data set, and we think that the more complex the model is, the better prediction we can get. So that's why we want to try the neural network, and we might put some time to build a neural network model to predict the low end status, and maybe we'll get a good result. And I have tried the MLP classifier, and it's not a good one. So that's it, and that's it. This is our work. Thank you so much.